Hello, everybody, and welcome to the Algebra edition of our GMAT Ninja Quant video series. It's so great to have you with us. We're going to go ahead and dive right in, but if you hadn't had the chance to check out our arithmetic video, there's a lot of things that we covered in that video that are going to be foundational for this video as well. So if you hadn't had a chance to check it out, go ahead and check that out. But before we dive in, I want to talk about whether this video is for you and what we'll cover in this video. So first, I want to talk about whether this video is for you. This video could be for you for several reasons. Number one, if you want to learn or if you need to learn or review the basics, maybe you're just starting your study for the GMAT, or maybe you started your study for the GMAT a while ago and you want to brush up on the basics. Well, this video will be a great opportunity to do that. We'll cover a lot of the basics. Several foundational topics that appear throughout the GMAT will be covered in this video. Second, if you feel like you know everything, but you still struggle, then this video will likely be helpful for you. Maybe you've been studying for a long time. We see many students who have been studying for a long time have spent a lot of time and often a lot of money studying for the GMAT. They feel like they know everything. There's not a formula in the book that we can give them that they don't know, but they still struggle. And so if you fall into that bucket and you say, I know everything, I know all the formulas, I still struggle for some reason, and I can't figure out why, then this video is likely going to be very helpful for you. And finally, if you lack efficiency or flexibility, this video will be very helpful for you. One of the things that will come up very often throughout this video is finding the best way to solve a particular question, not the first way that comes to mind. We'll talk about having multiple approaches to solve a particular question and always trying to figure out what is the best way to solve that question. So all three of those are good reasons that this video could be helpful for you. In this video, there's several topics that we'll cover. Over here, you can see I've written them on the board. The first one is we'll talk about simultaneous equations. Simultaneous equations show up fairly frequently on the GMAT, and they often show up in hidden or disguised ways as well. So we'll talk about simultaneous equations. We'll talk about quadratics. As many of you know, the quadratics show up very often on the GMAT as well. So we'll talk about where you can see quadratics, the basics of quadratics, hidden quadratics, all of that. We'll cover the basics of inequalities and the basics of absolute values as well. And one of the things that's going to be very important throughout this video is we're going to talk a lot about using algebra. One of the things that we often see happen is when students encounter an inequality, or when they encounter an absolute value, or sometimes even when they encounter a quadratic, their first strategy is to go right to picking numbers or to guessing numbers, testing cases. And so throughout this video, we're hopefully going to give you some of the tools that are necessary to avoid doing that. We're also going to talk about pushing questions in this video. That will be one thing that will come up fairly often. You'll hear me use the term push the question. And to push the question simply means this: get everything out of the question stem that you possibly can to make your life easier when you get to statements. It's particularly relevant on data sufficiency questions, although it shows up on some problem-solving questions as well. It's reframing the question, saying to yourself, what is this question really asking me? And finally, we're also, one of the themes of this video will be is that we often see on the GMAT variables where we'd expect numbers and numbers where we'd expect variables. But remember that algebra is your friend. You're going to want to use all the algebra tools that you have in your toolkit. And so this video is going to be all about providing you those tools and applying those tools in several different situations. So without further ado, I want to dive right into this first question. I'll go ahead and I'll pop this one up on the screen. Wonderful. Hopefully you had a second to sort through this problem. And I know we started off with one that's fairly easy, but the truth is that we often see students stumble on a question like this. And typically the error we see most frequently is that as students look at a question like this, and I'm going to go ahead and show you my board, and I've got it written up here, but oftentimes what we'll see is that students who struggle with a question like this are very quick to right away say, okay, what is the value of x? I've got two equations, two variables. I've seen this a million times all throughout elementary school, middle school, high school. I've seen this over and over. Two equations, two variables. I know how to solve it. Okay, C. However, what we don't want you to do is we don't want you to jump right away to something like that, because you're bound to make, or you're likely to make, a careless error. What you're going to want to do here first is you're going to want to simplify this equation. So for example, with statement 1, what I see is this is 6x minus 9y is equal to 24. Well, what I'm going to want to do here is I see that each of these terms has a factor of 3 in it. And so I'm going to factor out a 3, and what I'm going to say is that, okay, 3 times 2x minus 3y is equal to, and on this side, I notice that 24 also has a 3 in it, so I'm going to say 3 times 8. What I can do then is I've got a 3 on both sides, so I can divide by 3. It's going to cancel the 3 on both sides. And what I get to is an equation that is 2x minus 3y is equal to 8. Now, oftentimes what we'll see students do is go beyond this step, and rather than say, okay, 2x minus 3y is equal to 8, that's okay, I've solved far enough. What they'll do is they'll end up solving for x. And they'll say, well, I'm going to add 3y to both sides, then I'm going to divide by 2, and so you get that 4 plus 3, x is equal to 4 plus 3y over 2. And that's not necessarily the most efficient way to solve this question, because one of the things that comes up pretty often on the GMAT is that usually during middle school, high school, when you, in your past experience with simultaneous equations, the best way to solve simultaneous equations has been with substitution. Well, the people who write the GMAT know that, and oftentimes you'll encounter questions where or simultaneous equations where really the best way to solve those simultaneous equations is not through substitution, but instead through elimination. And so an inefficient way to solve this would be to take this a step further and try and do substitution here. However, I could just leave statement 1 like this, and I can look at statement 1 and say, okay, if 2x minus 3y is equal to 8, I've pushed that plenty far enough. I know I'm not going to be able to get to a solution. With statement 2, now when I have two equations with two variables like this, I don't necessarily need to solve all the way, but I do want to get these equations in the same format. Okay, and so what I'm going to do is I'm going to, on this particular equation, I'm going to take this, I'm going to add 4 to both sides, and I'm going to subtract 1.5y from both sides. And what I'm going to get is that 4 is equal to x minus 1.5y. And then what I'm going to do, just to make sure that I am going to be able to solve this particular equation, is I'm going to line it up here, and I'm going to say, okay, x minus 1.5y is equal to 4, because the one thing that I know is I do need 2 different equations. And what I'll quickly notice here is that if I multiply this second equation by 2, I get 2x minus 3y is equal to 8. And if I do that, what I have here is not actually 2 different equations. What I have here is really one equation that's just been divided by 2 in this instance, where if I were to divide the equation by 2, I'd get x minus 1.5y is equal to 4. And so really what I have here is I have the same equation given to me in 2 different ways. So I'm not actually going to be able to solve this, even though it feels like I have 2 equations with 2 variables. Okay. One way to think about the fact that I'm not going to be able to reach a solution here is if you think about this graphically, if I were to draw a graph of 2 different equations, then the solution to those 2 equations would be the point at which those lines intersect. If I were to graph the equations, the point at which the two lines intersect is going to be the solution to the two equations. However, what I have here is really not two different lines. What I have here instead is one line that's going to be just like that. I don't know if it has a positive slope or a negative slope. I'm not going to necessarily go through all that, but I have one line that's like that and a second line that's the same. And so there's not just one single point of intersection. So there's not just a single solution. In fact, there's infinitely many solutions to an equation like this. So key takeaways from this are, number one, we don't necessarily want to go right to substitution, because oftentimes on the GMAT, substitution isn't the most efficient way to solve things. Number two, things aren't always as they appear. So it may look as if I have two different equations. I could certainly solve for the variables with two equations, two variables, but you're going to want to check and make sure that you truly have two different equations. With that in mind, I want to take a look at the next question here. Wonderful. Let's take a look at this question here together. So the question asks, what is the value of x? And I'm told in statement one tells me that 5x plus 5y is equal to 25. Statement two tells me that 3x plus 3y, 3 in parentheses x plus y is equal to, and I'm sorry, I forgot a negative there, negative 3 in parentheses y minus x. So as I look at this with statement one, right away I'm able to see that statement one's not sufficient. Now, knowing what I know from the previous question, I may quickly just think to myself and say that I could factor out a 5 from both sides, divide the whole thing by 5, and say that x plus y is equal to 5. But obviously still I'm not going to be able to solve with statement one alone. When I look at statement two, this is interesting. So the danger here is to look at this and say right away, okay, I have two equations. I have one equation with two variables I'm not going to be able to solve for anything. But that's not necessarily the case. What happens here is when I distribute the 3, I get 3x plus 3y is equal to negative 3y plus 3x. And what I'm going to see here is that actually the 3x eliminates from both sides of my equation. And what happens is that I can add 3y to both sides, and I can get that 6y is equal to 0. And that's going to tell me then that y is equal to 0. Now, there's a few things to think about here. Number one, I'm able to solve for y here, but I'm not actually able to solve for x. Because if I take y and I plug back in 0 for y, I'm not able to actually solve for a value for x, because what I'll get is that 3x on the left side of my equation is equal to 3x on the right side of my equation. And obviously, when I divide by 3, all I'm going to get is that x is equal to x, which doesn't actually tell me any information about x. So I'm still actually not able to solve with statement 2. However, I was able to get out some information about y, and had this question asked, what is the value of y? Well, statement 2 alone would be sufficient, and the correct answer would be B. One other thing to note here, a common mistake that we see students make is when you get to the point where you say that 3y is equal to negative 3y. So if I say that 3y is equal to negative 3y, oftentimes the biggest mistake that I'll see students make is that they divide both sides of this equation by y. And they say, well, I divide both sides by y, the y's cancel, and 3 is equal to negative 3. But wait, that's a little bit of a problem. The reason that you can't do that is that you can't divide by a variable unless you know that that variable can't be equal to 0. Because you just, in general, can't divide by the number 0. And so because you can't divide by 0, you can't divide by a variable unless you know that variable can be equal to 0, can't be equal to 0. So what's a better practice is exactly what we did here. Pull everything to one side. Okay, so add 3y to both sides. 6y is equal to 0. And then I'm able to actually solve for the fact I can divide by 6. 0 divided by 6 is 0, and I can say that y is equal to 0. So another one to look out for. But from statement 2, all I get is that y is equal to 0. I'm not actually able to solve for a value of x. And so with that in mind, then when I look at both statements together, well, statement 1 I had simplified to x plus y is equal to 5. Statement 2 I had simplified y is equal to 0. So x plus 0 is equal to 5. Pretty easy to solve that and say that x is going to be equal to 5 here. So good thing to keep in mind on this question is number 1, just because I have an equation with 2 variables doesn't necessarily mean that I'm not going to be able to solve for the value of one of those variables. And the second thing is that I don't want to divide by a variable unless I've been explicitly told that that variable, or sometimes in some sort of shady way, the GMAT will hint at that for you. For example, they'll say, x times y is not equal to 0. But unless I know that the 2 variables that I'm dealing with can't be equal to 0, then I'm not going to be able to divide by those individual variables. So with that in mind, I want to take a look at another question here. Let's take a look at this one. Wonderful. Hopefully you've had a second to work through this one here. And as we talk about this one, so the question again asks us what the value of x is. And statement 1 tells us that x plus 2y plus 3z is equal to 6. Statement 2 tells us that 3x minus 2 plus 4y is equal to negative 6z. I put this one up here on the board. And as you can see, Statement one, pretty quickly, hopefully, with each of these, you recognize, okay, statement one's not going to be sufficient. Statement two is not going to be sufficient. One thing that I may do, though, when I see statement two here is this, is that I may look at it and say, okay, so I'm told that 3x, I may try and rearrange it so that it looks a little bit more like statement one. So I may rearrange it and say, okay, 3x plus 4y plus 6z is equal to 2. And the reason that I'll do that is because I want to rearrange, I want to be able to see things in a manner that's going to make them a little bit more clear. That's going to, and if I can kind of line up my terms here, maybe I'll be able to see something. But pretty quickly, you should recognize that neither of these statements by themselves is going to be sufficient. So with that in mind, that I'm gonna think about these two statements together. Now, the common error here would be to say, okay, I have two equations, I have three variables, there's no way I'm going to be able to solve this. Another mistake here would be to say, well, okay, this with statement one here, I can actually pretty easily solve for x, and I could say x is equal to 6 minus 3z minus 2y. But that would be kind of an inefficient path forward. That would kind of set you up to fail, because again, like we've said earlier, substitution on the GMAT, elimination tends to be your friend on the GMAT more often than substitution. Partially because the GMAT just loves to take easy topics, easy concepts, elimination that you learned way back in grade school, but that then you learned, well, I should just always use substitution, and you forgot about it, and they love to bring those easy topics back out and see if you're able to apply them in your later years. So in any case, what I want to do is, real quickly, what I see is this, is that if I look at statement one and statement two, and again, I'm trying to solve for x. The two terms that I'm trying to get rid of here are my y term and my z term. My y term and my z term here. And what I notice is this, is that 4y is a multiple of 2y, 6z is a multiple of 3z. In fact, if I multiply my first equation by 2, then I'm going to get 4y and 6z in this equation, and I'm going to be able to eliminate things. But what I'm going to do is this, is rather than multiply by 2, I'm going to multiply by negative 2. And the reason I'm going to multiply by negative 2 is this, is I'm going to get negative 2x minus 4y minus 6z is equal to negative 12. And then I'm going to look at statement 2. I'm going to bring that over here, and I've said that 3x plus 4y plus 6z is equal to 2. When I add these two equations together, and again, one of the reasons that I multiplied by negative 2, it was so that I could add my equations rather than subtracting. Subtracting equations, when you've got to remember that you're subtracting for 4 different terms, you're kind of likely to make an error. And number 2, when we get to inequalities, we'll talk about inequalities in a bit, but with inequalities, you can add inequalities, you can't subtract inequalities, so it's better to be in the habit of adding equations anyway. But when I look at this, if I add these two equations together, then I'm going to get x, my 4y and negative 4y are going to cancel, my 6z and negative 6z are going to cancel, and I'm going to get that x is equal to 10. So even though I didn't have particular values for y and z, and even though I wasn't able to solve for them, I was able to solve for the value of x. And kind of the punchline here for these past 3 problems that we've looked at is that the GMAT loves to mess up all the algebra that you learned back in grade school. They'll give you 2 equations with 2 variables, and you can't necessarily solve it, even though you always thought that you could. They'll give you, 2 equations with 3 variables. And again, it feels like you probably can't solve that, but you actually can, like you saw here. Or like we saw in the previous question, they'll give you 1 equation with 2 different variables. And in that 1 equation, you'll be able to solve. So the GMAT loves to take that combine those basic skills that you learned in grade school and give them a little twist and see if you're able to handle that twist. With that in mind, we're actually going to look at another question that does that in a little bit of a different fashion. And so I want to take a look at this one. Take a second. I'm going to put it up on the screen, give you a minute to solve it. And then after that, after you've had a chance to solve it, we'll talk through it together. Hopefully you've had a chance to look at this question, and let's dive in it and take a look at it together. So the question asks, if 2 over x plus 3 over y is equal to 3, then what is the value of x in terms of y? When I look at this together, let's go ahead and take a look at the board. This question, it's pretty clear to me right away that I'm going to have to do some things to this equation to make it look something more like what I've got here in my answer choices. And so I've got 2 over x plus 3 over y is equal to 3. And what I'm going to do is I'm going to start to think about, what is it that I want to do here? Well, really what I want to do is I want to combine like terms. But I have a little bit of a problem when I have x and y in the denominator, and contrary to somewhat popular belief, I can't actually just flip the fractions and say that x over 2 plus y over 3 is equal to 1/3. Can't do that. And so instead what I'm going to have to do is I'm going to have to start to simplify. And this is one of those GMAT questions that you see where you don't necessarily know what the precise path forward is. But what you've got to do is you've got to just say, well, what can I do? What can I do to take this question and push this question forward a little bit? So when I look at this, when I say, what can I do? Well, I can simplify my denominator, give myself a common denominator. So I'm going to multiply 2 over x by y over y. And again, because y over y is equal to 1, I can multiply 2 over x by y over y. So I'm going to get 2y over xy. And then I'm going to do a similar thing to 3 over y. I'm going to multiply it by x over x. And so I'm going to get 3x over xy. And all of this, of course, is still equal to 3. What I'm able to do now is I'm able to combine these two into one single fraction, and I'm able to say that 2y plus 3x over xy is equal to 3. I can pull my xy term to one side, and I can say I can multiply both sides by xy, and what I'm going to get is 2y plus 3x is equal to 3xy. And from here, I'm going to, again, go back to what am I trying to do? What is it that I'm trying to accomplish? Well, I want to know the value of x in terms of y, which means I'm going to have to combine like terms, and I'm going to have to isolate my x term. I want to know x is equal to something y, some version of y, right? I can't have an x term in my answer. So what I'm going to do is, because I want to isolate my x, I'm going to subtract 3x from both sides. And what I'm going to get here is this, is that 3xy minus 3x is equal to 2y. From here, I'm going to be able to say, let me go ahead and erase this top part of the board to give myself a little bit more room. But from here, what I'm going to do is this, is I'm going to say that I can actually, again, I'm looking to isolate x. Well, I can isolate x by factoring out an x. So I'm going to bring this up here, and what I can say is this, is I can factor out an x from the right side of my equation and say x times 3y minus 3 is going to be equal to 2y. From here, of course, I can say that then x is equal to 2y over 3y minus 3. Now, here's where things can get a little bit complicated, because x is equal to 2y over 3y minus 3, and I kind of glance at my answer choices, and okay, it kind of looks a little bit like C, looks a little bit like A, but I actually don't know which one of them it's going to be. Well, here's where I've got to know how to tweak, the answer that I've got to make it look like one of the answer choices that I have down here. I don't want to say, well, C looks like it, so it's C, or A looks like it, so it's A. Well, what I'm going to do instead is this, is I'm going to factor out a negative from the bottom, which means on the bottom, instead of 3y minus 3, I'm going to get negative 3y plus 3. And I'm going to pull that negative out of the bottom, and I'm going to stick it on top instead. Because again, it's like a negative on the bottom or the top, it's not going to make a difference, right? Negative 1 over 1 is negative 1, right? 1 over negative 1 is also negative 1. So it doesn't matter whether the negative's in the numerator or in the denominator. And what happens is this, is so x is now equal to negative 2y over negative 3y plus 3. Of course, that's the same as answer choice A. Answer choice A just flips the place of 3 and 3y in the denominator. And so A is the correct answer here. This is a great GMAT question because it combines a lot of simple skills. And oftentimes what we think are hard GMAT questions are really just a compilation of a lot of simple, easy skills. And so for a question like this, you've got all sorts of different, skills, easy skills that you learned in grade school that the GMAT combines. You got to add and subtract fractions. You've got to eliminate fractions. You've got to combine like terms. You've got to factor, and you're looking at an answer choice that doesn't necessarily look exactly like the answer that maybe you came to. And so again, it's just a matter of oftentimes for complex questions on the GMAT, combining easy skills. So sometimes, I don't necessarily know what the precise path forward is. Well, okay, let me push the question. Let me see what can I do. With that in mind, I want to take a look at another one here. I'll give you a second to solve it on your own, and then we'll talk through it together. Awesome. Hopefully you've had a second to work through this one. And this one, at first glance, can be kind of an intimidating question. What's the square root of 505 squared minus 495 squared? So when we look at this one on the board, one of the things that I want to point out to you is this, is that the question by itself, what's the square root of 505 squared minus 495 squared, looks kind of intimidating. And again, kind of the first instinct when I look at a question like this is, what in the world am I supposed to do, right? And the hardest thing is figuring out that first step. But this is where I would say that the principle we talked about in the intro to this video of looking for numbers where you'd expect variables and variables where you'd expect numbers can actually become really important. Because you may look at this and say, I'm stuck, I have no idea what to do. But I'd imagine that if I gave you this question, what's the square root of x squared minus y squared, you would at least have some idea of what to do. Now, you may not be able to, obviously you're not going to get to any of these answers, but at least in your mind, there would be something that would go off and say, well, hey, there's something I could do with that. And again, I think that's because you expect variables when you're dealing with these special quadratics, and you don't necessarily expect to see numbers when you're dealing with these special quadratics. And so the best first move here is actually to, again, ask yourself, okay, what can I do? And when you start to ask yourself, what can I do? Well, if I had variables, the first thing I would do is say, okay, that's just x plus y times x minus y. So what happens if I do that here? Well, I could say that this is 505 plus 495 times 505 minus 495. And what that's going to give me is going to be, and again, the square root of that, I'm going to carry the square root symbol down here. What that's going to give me is that's going to give me the square root of 1,000 times 10. Of course, 1,000 times 10 is 10 to the third times 10 to the first, or you could say that's going to be 10,000. And when I take the square root of 10,000, that's going to be equal to 100. Now, a couple things that are worth noting here. First thing is this, is that one of the things that we often see, or one bad way that we often see students kind of work through this similar question is that they'll say, well, okay, so 505 squared, well, I could call that 500 plus 5 squared minus 500 minus 5 squared. And they end up doing out all that sort of arithmetic, and it ends up getting pretty complicated pretty quickly. Now, you can cancel things and you can maybe get to an answer doing that, but it's definitely not the most efficient way. And again, if you've had the chance to watch the arithmetic video, one of the themes of this video as well is I want to look for the most efficient way to solve a problem. You know, it's not success on a problem if I figured out how to solve it. I got the answer right. That's not necessarily success. We want to redefine the way you think about success. Success is, did I apply good technique? Did I go through those 4 steps that we talked about in the arithmetic video? Did I also find the most efficient way to solve the problem? And this is going to be the most efficient way to solve the problem. Another thing to think about is now on a question like this, where I'm asked what 505 squared minus 495 squared, the square root of that is equal to, one of the things that will often come up is this, and is that students will say, well, couldn't it also be negative 100? And this is a little thing to know about the GMAT that a lot of people don't realize. But when the people who write the test, so just to be clear, the answer would be C, but when the people who write the test use the square root symbol on the test, for example, if you see the square root of 100 written on the test, they mean take the positive square root. Okay, that symbol to them means to take the positive square root. Whereas we could say that the square root of 100, well, we know that the square root of 100, we've got to take both the positive and the negative square root. So that's going to be equal to plus or minus 10 right? But when the square root symbol is written on the test, it means to take the positive square root because that's what that symbol means for them. Now, typically shorthand, we'll just use that same symbol to mean take the positive and negative square root in our own work. But when you see that symbol on the test, it means to take the positive square root of that number. So if I see this written on the test, that's actually not equal to -10 on the test. Of course, if I'm given 100 and they ask me to take the square root of it, for example, they say, what is the square root of 100? And they write it like that, okay, then I can say the square root of 100 is positive or -10, right? But if that symbol, to the test writers, the people who write the test, it means to take the positive square root. So that's always the case on the GMAT. So with that in mind, that's just a little note that'll come up in some later questions. We'll actually see a question later where that becomes really important. So just tuck that away in the back of your brain. There are some questions on the GMAT where that shows up as well. But with that in mind, I want to take a look at the next question here together. Hopefully you've had a chance to look through this one, and we're going to take a look at it together. But from the get-go, it looks like a pretty straightforward question. I'm asked, what is the value of xy? And so, like I said, pretty straightforward. There's not much I can do to push the question, but let's take a look at this one on the board. So I'm asked about the value of xy. Statement 1 tells me that x squared plus y squared is equal to 169. So I'm gonna, when I first look at that, I may say, okay, what can I do with this? Maybe I could pull y to one side, but again, I've got one equation. I've got two different variables here, and I'm definitely going to be able to come up with multiple solutions for x and for y that are going to get me to 169. Likewise, when I look at statement 2 by itself says that x plus y is equal to 17. Well, that alone isn't very helpful to me. Just knowing that x plus y is equal to 17 doesn't really do a ton for me. And so that statement as well, there's infinite possibilities for x and y, which are going to give me all sorts of different values for x times y. So that statement alone isn't very helpful either. However, I'm going to start to think about these two statements together. And again, this is where that whole idea of what can I do is going to come into play and is going to be super important. Because when I look at these two statements together, I know that I'm trying to solve for xy. And I know that x squared plus y squared is equal to 169. Now, it's going to take a lot for me to get that sort of information into a form that's going to be helpful for me. I'm going to have to take square roots, and I don't know that is going to be super helpful for me. But what I can do is this, is that I can say that I know that x plus y is equal to 17, and I can make this equation start to look a little bit more like that one. So I could say that x plus y squared is going to be equal to x squared plus 2xy plus y squared, which is also going to be equal to 17 squared. Got to square both sides. So 17 squared. Now from here, I know that x squared plus y squared is equal to 169. 169, I'm going to rewrite that just for my own sake as 13 squared, just to make my life a little bit easier. And so I know that then 2xy is going to be, 2xy is not going to be equal to 2xy plus x plus y squared, x squared plus y squared, is going to be equal to 17 squared. I can rewrite that as 2xy plus 13 squared is going to be equal to 17 squared. And from here, I know that I'm going to be able to solve for the value of x times y. I can subtract 13 squared from both sides. I can divide by 2. So at this point, I feel comfortable stopping. Now, the reason I rewrote things as 13 squared instead of 169 is if I happen to be on the GMAT, and this happened to be a problem-solving question, and I really did need to solve for the value of x, y, then I would want to write it as 13 squared, so I could do 17 squared minus 13 squared, and all of a sudden I'm dealing with the difference of two squares, and that's going to be 17 plus 13 times 17 minus 13, which I think is going to be a little bit easier because I don't know 17 squared off the top of my head. I think that'd be a little bit easier way to do the arithmetic there to be able to solve that. So from here, I'm going to be able to solve for the value of x and y. Now, this is a great question, and a question I love to go over with my students. And the reason for that is this, is because it's very common of the GMAT to take these kind of quadratics, these special quadratics, x plus y squared, x squared minus y squared, x minus y whole squared, and take those and then twist them or hide them or tuck them away in different problems. And so they often come up in ways or in areas that we don't actually expect. If you've had a chance to check out our geometry videos, what you'll see in our geometry videos is that this is actually similar to a geometry problem that comes up pretty frequently on the GMAT. If I were to tell you that x and y were two side lengths of a rectangle, then what I have here is xy is asking for the area, x squared plus y squared is giving me the diagonal squared, and then x plus y is similar to the perimeter, right? It's half the perimeter. So this concept will show up in different ways. The GMAT loves to mix concepts, so oftentimes you'll see kind of a geometry version of this question where they give you two of these three pieces. They give you maybe the perimeter and the diagonal and ask you for the area, or they give you the diagonal and the area, they ask you for the perimeter. You'll often see that on the GMAT because the test just loves to mix questions. And so just tuck that away in the back of your mind that you always want to be on the lookout for where these quadratics could be hidden or could be ultimately helpful to you. With that in mind, let's go ahead and take a look at this next one. Awesome. So hopefully you've had a chance to work through this one. And one thing that you'll see here, so the question asks, if the absolute value of x plus 4 is equal to 7, then which of the following represents a possible value of x squared? And has several answer choices. But I want to take a look at this one together on the board here. And I want to give many of you, I would imagine if you're watching this, everybody kind of has their own way to look or to think about absolute value or solving equations with absolute values in them. And I think probably the most common way that people are going to solve this one is they're going to look at it, they're going to say, okay, the absolute value of x plus 4 is equal to 7, right? So from here, I can split it up into two equations. I can say that x plus 4 is equal to 7, or x plus 4 is equal to negative 7. I can subtract 4. I can say that x is equal to negative 11. Over here, I can say that x is equal to 3. So x is equal to 3 or x is equal to negative 11. And for this question from here, you'd go on, you'd square it. You could say, okay, x squared could be equal to 9, or x squared could be equal to negative 11 squared, which happens to be 121. So E is going to be the right answer here. But I actually want to give you another way to think about these absolute values that could be helpful. Again, I'm not necessarily opposed to this method of solving. I will tell you that I am opposed to one thing that we see at times is squaring both sides here, right? Squaring both sides here is unnecessary. Hopefully you're able to do something as simple as this. But there's another way to think about absolute value that I think is pretty valuable and I think is worth covering here, and that's this. Absolute value at its core can be a measure of distance, right? So if I say the absolute value of x, in theory, what the absolute value of x tells me is it tells me the distance of x from 0, right? If x is 7, the distance of x from 0 is 7. If x is negative 7, the distance of x from 0 is still 7. And the reason for that is because I can't have negative distance. And so the absolute value of x is going to tell me the distance of x from 0. Now, this comes into play because when I have something like, for example, the absolute value of x minus 3. So typically, if I set up an equation and I say, x minus 3 is equal to 7. Well, what that's telling me is the distance between x and 3 is 7. Well, actually, literally what it's telling me is that the difference between x and 3 is 7. And obviously here the x would be equal to 10, and you'll notice that 10 is 7 away from 3. The reason, though, that subtraction, normally we would say subtraction tells me the difference and not the distance, is because the difference can be negative, whereas the distance can't be negative. But otherwise, when I use subtraction, it gives me a pretty good idea of the distance between two numbers. So the absolute value of x minus 3 is actually going to tell me the distance between x and 3. If I said the absolute value of x minus 7, well, that's going to tell me the distance between x and 7. If I were to change things up a little bit and I were to say the absolute value of 6 minus x, well, okay, that's going to tell me the distance between 6 and x. And you'll notice here that's actually why it's the case that the absolute value of x minus 3 is equal to the absolute value of 3 minus x, because the distance between x and 3 is equal to the distance between 3 and x. However, if I change things around here, and let's say I have the absolute value of x plus 7, well, I could think of the absolute value of x plus 7 as the absolute value of x minus negative 7, right? Minus negative 7 will be is the same as plus 7. And so that's going to tell me the distance between x and negative 7. If I were to say the absolute value of x plus 4, that's going to tell me the distance between x and negative 4. Now, it's just helpful to have this second way to think about absolute value in the back of your mind, because at times it can provide for you a more efficient path to the solution. So when I think about this question, for example, and again, I wouldn't say necessarily that this question, thinking about things in terms of distance, is a more efficient path, but there are questions where it can provide you a more efficient path to the solution. And so here, for example, if I say that the absolute value of x plus 4 is equal to 7, remember, we said the absolute value of x plus 4 is the same as the absolute value of x minus negative 4. So it's telling me that the distance between x and negative 4 is equal to 7. Well, if I think about that on a number line, I have -4 here, I have 0 here, and I know that the distance between x and -4 is 7. So if I go 7 to the right of -4, I'm going to get 3. If I go 7 to the left of -4, I'm going to get -11. And so one way that I can think about absolute value is in terms of distance, and that's going to be helpful as we get to some more advanced questions with absolute value, which we'll get to not just in this video, but in videos to come. We're going to cover even more advanced concepts like these. So let's take a look at another question here. Awesome. Hopefully you've had an opportunity to work through this one here. And again, this one seems like a fairly straightforward question from the get-go. Is x less than 5? Let's take a look at it here on the board. And one of the ways that I'm going to want you to think about this one here is this, is we're going to want you to think about this visually. So if I think about a big number line, the question that's really being asked for me is this, is if 0 is here, 5 is here, the question is, does x fall in this range to the left of 5 on my number line? When I start to look at the statements, things get a little bit more complicated. The first thing I'm going to do right away here with statement 1 is I'm going to simplify it. When I simplify it, I'm going to get that the absolute value of x plus 4 is less than, and I'm going to add 3 to both sides, so I'm going to get 18 and then I'm going to divide by 2, and I'm going to get 9. So the absolute value of x plus 4 is less than 9. And right away, I'll say this, that one of the most common mistakes that we see students make on this particular type of question is that they'll go right to guessing numbers. Guessing numbers, testing cases. Let me see if I can come up with some numbers that'll work for this inequality. And if they work for this inequality, then do they work for the question? And what happens is all of a sudden things get really foggy because number one, you got to keep everything straight in your mind. And that can be really hard. And sometimes there's charts that people use to help them with that. But even then, it's hard to keep track of everything. Number two is this. For a question like, is x less than 5? One of the things that I'm going to encounter here is this, is how do I ever know if I've tested enough cases, right? I could test all the possible values less than 5 for x, but I'd still wonder to myself whether, is there some value greater than 5 that I just haven't tested yet? And so that creates a lot of problems here. With that in mind, I'm going to think about statement one in kind of a unique way, and I'm going to use a lot of the tools that we learned about on the previous question to kind of help here. So it tells me that the absolute value of x plus 4 is less than 9. And you remember that on the previous question, we talked about thinking about absolute value in terms of distance. So I could say that the absolute value of x plus 4 tells me that the distance between x and negative 4. So negative 4 is kind of a key point for me here. And I know that the distance between x and negative 4 is less than 9. Well, so I'm going to start to write that out on the number line that I've drawn here. If I know that the distance between x and negative 4 is less than 9, well, what's 9 to the right of negative 4? 9 to the right of negative 4, I'm going to find 5. So I know that, which again, I've already drawn up here, I know that the distance between x and negative 4 is less than 9. Well, if I bring x to the right of 5, then all of a sudden the distance between x and negative 4 is going to be more than 9. So I know x has to fall on the left side of 5 here. So that tells me that x from the first instance must be less than 5. So I know that x must be less than 5. I also know, and again, remember the distance between x and negative 4 is less than 9. I also know that there's another number that's 9 to the left of negative 4, which is going to be negative 13. And again, here, I know that the distance between x and negative 4 has to be less than 9. So x has to fall on the right side of negative 13. In other words, x is going to be greater than negative 13. And when I think about it like that, I'm able to pretty quickly see here that x has to fall somewhere in this range from negative 13 to 5. Of course, if x falls in the range from negative 13 to 5, then I know that x is going to be less than 5. Of course, x can't be equal to 5 because then the absolute value of x plus 4 would be equal to 9. So with that in mind, then I know that statement 1 is sufficient. And so now I'm going to take a look at statement 2. Statement 2 tells me that x squared is less than 25. Well, I could rewrite that, take the square root of this whole thing, and I can say that the absolute value of x is less than 25. I'm sorry, take the square root of the whole thing, so not less than 25, less than 5. The absolute value of x is less than 5. And if I know the absolute value of x is less than 5, again, thinking about things in terms of distance, the distance of x from 0 is less than 5, which means that x is going to be between the number that's 5 to the right of 0, which is 5, and the number that's 5 to the left of 0, which is negative 5. So from statement 2, x falls in the range of negative 5 to 5. Again, that's sufficient to tell me that x is less than 5. So this is just an example here of, and obviously there are algebraic ways that you could go about this as well, but this is just an example here of how thinking about absolute value in terms of distance can be super helpful. And what you see is that all of a sudden I don't have to guess numbers. I don't have to get into, well, do I flip my inequality? Do I not flip my inequality? When I just think about this logically, and I use logic rather than picking numbers or some other method, then I'm able to figure out really quickly that x is indeed less than 5. And of course, the answer here is going to be D. With that in mind, I want to take a look at one more question here, one final question together. And so I'll pop this up on the screen and give you a moment to work through it. Awesome. Hopefully you've had a second to work through this one, and I want to talk through it now together. The question is this: is x times the square root of x squared minus x equal to 0? And let's take a look at this one together on the board. The first thing that's going to pop out at me when I see this question is this, is that, okay, is x times the square root of x squared minus x equal to 0? When I see that, right away my instinct is going to be, is there any way that I can simplify this? Is there any way that I can push this question? Because for me to check each statement against this is going to be ridiculously challenging. So first thing that jumps to my mind is, can I make my question any simpler? Can I hopefully I can sort through things in a way that's going to make this much simpler for me. So first thing I'm going to note is this, is that when I say the square root of x squared, this is something that appears on the GMAT with some level of frequency. And what that means is this, is remember how we talked about how when you see the square root of 25 written on your test, that's going to be equal to 5, right? When they write this symbol on the test, because at its core, this symbol really means to take the positive square root. Now we use it in shorthand to mean take the positive and negative square root when we're doing our work, but at its core, that's what that symbol means. Really, if I were to say, what's the square root of 25, I would want to put positive or negative right there. It becomes a bit challenging to write that all on the test. So that would be the positive negative square root of 25 would be positive or negative 5, right? But when I take, so essentially what I'm doing, and I'm going to again think about order of operations here with the square root of x squared. First thing I'm going to do is I'm going to take x, I'm going to square it. Second thing I'm going to do is I'm going to take the square root of it. So when I take a number, positive or negative, and I square it, I'm going to get a positive number. Then I'm asked to take the square root of that positive number. Now remember, because this square root sign is written on the test, really what it's saying to me is take the positive square root of x squared. When I take the positive square root of x squared, again, because I'm just taking the positive square root of x squared, I'm not actually getting plus or minus x. I'm actually just going to get the positive version of x. So really what I'm getting is the absolute value of x. So the square root of x squared, again, because I'm taking the positive square root of x squared, is going to be equal to the absolute value of x. What I'm going to do here is this then. I'm going to simplify. I'm going to continue to simplify. I'm going to say x times the absolute value of x minus x. Is that equal to 0? And again, I'm going to simplify further. I'm going to say x times the absolute value of x minus x squared. Is that equal to 0? I'm going to take it one step further, and I'm going to say, is x times the absolute value of x equal to x squared? Now, again, here's where students can go wrong fairly frequently, is they'll go right to guessing numbers here, or they'll go right to guessing numbers from here, and they'll just plug in numbers and see if it'll work. What I actually want to do here is I want to think through this logically. In what instances is it going to be the case that x times the absolute value of x is equal to x squared? Well, I know that x squared is always going to be positive. And x times the absolute value of x is pretty similar to x squared. The only thing is, if x is negative, then I'm going to have a negative times a positive. I'm going to get a negative number over here. If x is positive, or if x is equal to 0, then what? Well, let's first start if x is positive. If x is positive, then I'm going to have positive times positive, which is going to give me x squared, right? So this equation, x times the absolute value of x, is that equal to x squared? Well, x times the absolute value of x will be equal to x squared as long as x is greater than 0, or, and again, you always don't want to forget about the instance in which x could be equal to 0, or if x is equal to 0, because obviously 0 times the absolute value of 0 is going to be equal to 0 squared. right? So all of a sudden my question becomes, is x greater than or equal to 0? Because again, if x is negative, that's the only instance in which x times the absolute value of x is not going to be equal to x squared. That question all of a sudden becomes much easier, because what I'm told here with statement 1 is that x, the absolute value of x times x is greater than 0. Well, I know the absolute value of x is going to be positive. I know that x then, for this thing to be greater than 0, for this whole thing to be greater than 0, x also has to be positive. So then I'm going to have a positive times a positive, and I know now that statement 1 alone is sufficient. When I look at statement 2, and again, that's because I can't have a positive times a negative here, and because that would give me a negative number. A negative number is going to be less than 0, so that can't work. So I know from statement 1 that x is greater than 0, which is going to be sufficient to answer the question, is x greater than or equal to 0. With statement 2, I'm told that x cubed is not negative. Now, this is typical GMAT language. It's just seemingly very confusing, but x cubed is not negative, right? So what that tells me then is that if x cubed is not negative, then that means that x cubed is positive, or I also want to remember the instance in which x cubed could also be equal to 0, because 0 is not negative. So what that tells me then is this, is that x cubed is greater than or equal to 0. Well, for x cubed to be greater than or equal to 0, I also know that x can't be negative. And the reason that I know that x can't be negative is because a negative times a negative times a negative is going to give me a negative, and a negative is not going to be greater than or equal to 0. So what I know is that from statement 2 also tells me that x is not negative, or that x is greater than or equal to 0. And with that, I'm able to solve this question. So this right here is just a taste of what's to come. You've probably seen many of those questions on the GMAT where you have something like this. You've got a lot of variables. You've got hard absolute value, hard inequality questions, and you just feel like you're at a loss. There's a lot of those questions that show up on the GMAT. We get questions all the time from students about those questions, about those types of questions. Well, in a future video, we're actually going to cover those types of questions where you get some data sufficiency question, and you often end up feeling like you have to guess. You have to test cases, or you have to guess numbers. We'll talk about that in a future video, and so stay tuned for that. This is just a taste of what's to come there, but hopefully this has all been helpful for you. Hopefully this has been a chance for you to learn and refresh on some of those algebra skills. Remember some of the big takeaways from this video. Remember what we covered at the beginning about simultaneous equations. The GMAT loves to give you simple algebra, and a bunch of simple steps together end up seeming complex. Remember to push the question. Remember that you're always going to want to think about, what's the best path forward, not what's the first path that comes to mind. Those are all key things. And remember that you don't want to be testing cases. You want to be thinking logically. You want to use algebra. Algebra is your friend. Guessing numbers, testing cases is not your friend. And so all of that is, and again, this is just a taste of things to come. In a future video, we're going to cover even more questions like this that are going to get even more complex, and we'll go into those in further detail. I hope this has been helpful to you. Thank you so much for watching, staying tuned with us. I hope that this helps enhance your GMAT study, and we look forward to seeing you in further videos.